Hello and welcome to yet another session at NestGen 2024. Hope you're having an amazing Saturday. Please drop in a message in the chat section and let me know what you do, where you're coming from, and what do you think about this session. During the course of the next 30 minutes, we'll be discussing how on-premise drone-in-the-box deployments are being made possible for a rather interesting use case, that is monitoring air quality. AQI is a pretty common term. Every year, millions of people suffer from lung illnesses caused by PM 2.5 particles. It is more important than ever to figure out an innovative and sustainable solution to measuring air quality. In today's session, we'll learn how MetaPass has solved this problem for their region. Founded in 2016, MetaPass revolutionizes industrial data management by integrating drones for facility inspection and defect analysis across various sectors. By combining advanced drone technology, precision location management, and sophisticated computer vision, along with cloud-based applications. MetaPass is committed to pioneering solutions such as drone stations, real-time devices, and autonomous drones, aiming to transform traditional data collection, analysis, and management processes. With us today is Calvin Heo, the CEO of MetaPass. Calvin leads MetaPass, an innovator in solar PV inspections and AI solutions in the industry. His journey began in 1995 at LG, where he made significant contribution to the CDMA technology and standards. As a product manager at CK and CNC, he spearheaded the development of a comprehensive location-based service platform for major telecom entities. Before establishing MetaPass, Calvin advanced drone commercialization as a visiting researcher at ETRI. He holds a master's degree in mobile communication from Sungkyuan University. Now, some housekeeping rules for the audience. If you have any questions for Calvin, please use the Q&A tab on the right side of your screen, and Calvin will address those questions at the end of the session. These sessions are being recorded and will be shared to you over email right after the next ends. If you thought that these sessions brought some invaluable insights, please don't forget to share them on LinkedIn or Twitter with the hashtag NestGen. Now, before we begin, I would like to express gratitude to our sponsors for their unfettered support. Our title sponsors, DJI Enterprise, and gold sponsors, Sunflower Labs. Without any further ado, let's hear it from Calvin.
Okay, thank you for introduce me, Jet. Yeah, I'm very honored to the speaking this webinar. Yeah. Okay. Hello everyone. My name is Calvin He, and I'm at the CEO of the MetaPlus. I'm very honored to present at NestGen 24 today. Yeah. The topic I will be presenting today is exploring on-premise doctor deployment for air quality monitoring. Through this topic, I will briefly introduce the project in which MetaPlus provided an automated drone air quality monitoring solution on on-premise basis at the end of the last year. First, let me briefly introduce our MetaPlus product solution. Here's the MetaPlus. MetaPlus is the company that provides the platform and the service using drones. In particular, we provide the platform to inspect the PV modules of a solar power plant in the new renewable energy industry using drones. To analyze the defect and the PV modules, we use the AI engine our developed for finding defect and then managing the visualization them. We also provide the drone station and the service using drones, such as the wildfire monitoring. This is our solution Solvit, solar power plant PV module inspection solution. This solution is composed of three modules. The first one is a drone equipped with the RTK GPS for imaging solar power plant. Of course, the inspection using DJI drones is also possible. The second is the AI engine modules that automatically analyze, capture the images, and localize the location of the defect. And finally, the third one is the platform module that visualize this data using our GIS system so that the stakeholders can get the insight of their solar plant. And next is the drone stations. Uh, we also is provide the drone station. This drone station is automatically take off and the landing, and then also there's automatically a battery exchange feature using the robot arms. It's a universal robot arm we using for the battery changing. And also we can monitoring and control the whole the drone and then drone stations. Lastly, the wildfire monitoring service. This is a service that monitor the forest fire area by the mounting the drone station in a specific area or the moving in the vehicle is kind of the trucks. When the smoke is such as the forest fire is detected, the authorities is notified using a message. It's kind of the uh, WhatsApp, something like that. Up to this point is I have to briefly explain our metaverse solution. Yeah. And the next, let's talk about today's main topic is exploring on-premise doctor deployment for air quality monitoring. The customer's problem was there was a large cement factory near the village in the rural area. So fine dust and the ultra fine dust were having a significant impact on the lives of the local residents. Additionally, the many dump trucks is transporting cement from the factory, so it's creating the lot of dust also. So as a result, is many complaint about air quality from the local residents continuously. So even if the fine dust measurement vehicle or drones are used to resolve the civil complaint, this is a one-time solution. It's not a sustainable solution. So more fundamental solution was needed. Al- Also, there is installing the air quality monitoring sensors around the factory, and the village is also expensive, and many lead to the areas not detected areas. So that was the problems. So we are provide the solution for to solve those problems. So the customers is wanted to solve these problems at the optimal cost. The customers is conditions requirement is including the minimizing the human intervention to reduce the cost, and then automatically monitoring air quality in a real time on a regular basis. Being able to the flexibility change the inspection route depending on the monitoring area. Also, from the management perspective, air quality monitoring solutions must be integrated to the customer's existing uh, um, integrated management systems. That was the very important issues. Uh, additionally, the service must be provided as seamlessly when the uh, air quality monitoring system is integrated with the customer's existing system, and then we have to provide the seamless service. So we supply the app and then enable automatic upright air quality measure and the return of the drone solution. So you can see uh, our solution is the Hextronics drone station, and then you can see there are drone, and then uh, the air quality measurement sensor is mounted on the front top of the drones. And the air quality measurement sensor can measure the dust above the PM2.5. Additionally, the LTE modem is built inside the air quality monitoring sensor to transmit the measured data to the data collection server. Also, if you look above you can see the snow is that means this solution is worked or well even in the very cold environment is exceeding minus 15 Celsius degrees. This is a layer diagram of the solution. It shows the simplified version of the uh, modules and the linking interface used in the solution. In this project, uh, you can see there is a drone station and then on-premise the cloud server, and then in customers integrated management system is using the customers VPN networks. So, because there's due to the customer's circumstance, those solutions have to be installed on-premise at the customer side. So there was another some very big our obstacles to provide a solution because the existing solutions is usually based on the cloud basis. So we have to there is a block our solution to the customers on premise. That was the it's maybe we need many effort to do that. Anyway, there is the so the also the another one is this system is have to be integrated to the customers solutions, existing solutions. So we developed the RESTful API based integration. So right now is fully support those kind of the working and then open the API based this. We successfully integrated this system integrations. So why there is customers is want to the integration their solution integrates the dual air quality measurement solution to their existing solution. That is they fully want to control and seamlessly monitoring these solutions. In order for the drone to begin the flight, uh, uh, is according to the schedule mission is that the operator must give the final approval. That is very important. So the customer's integration control system is automatically check the environmental information such as the rainforest and then wind speed and so on. So when those conditions are met, the system requests a final flight permission to the operators. It's a operator cellular phone, and then when the operator is received those message, and then operator can apply the final permission. After that, the drone can flight begins. So finally there is when the drone uh, measure this air quality is in real time. In that case, uh, the air quality is sent to the collection server, and then it's displayed on the digital signage around the building. So this is the rearrange the photos is the app, and then control solution is a priority auto, and then customers control center. And then we are provide this solution is yes customers problems is very effectively, yeah, we solve the problems. Thank you for listening for to the presentation.
All right, Calvin. I think people got a lot to learn about how air quality monitoring at scale can be achieved by such a solution. I think now we can move on to questions. So I would request all the audience to share their questions in the Q&A tab, so Calvin can take it up. So Calvin, there are already a few questions in the Q&A section. So I will just take that up, and you can answer them. One question is, which sensor was used for air quality sensor? Like, which was the sensor used for air quality monitoring?
It's kind of the radar sensor, and then made by the third party solutions.
Okay, right.
Mhm.
So it's a radio sensor. All right.
Mm.
Okay, I hope that answers the question. How has on-premise deployment served beneficial for your use case? Is on-prem better than an cloud-based solution or an air gap solution? It says.
I think it's a choice. It's according to the customer's circumstance. Our customers is some government, so they try to block their networks from the uh, commercial public network. So they have to install the it's on premises, and then those collecting data have to be keep their inside networks. So that they choose this on-premises solutions.
All right. Oscar has asked a question in the chat. He says, because the sensor is too close to the drone, does it not generate an error due to the airflow generated by the drone itself? Uh,
Yes, there is a good question. Is the sensor actually that you can see this very closely connected to this drone, and then I think it's the airflow is there's no problem. However, there is the sensor is too close to the drone, and then sometimes it's block some GPS signals, and then make some noises. So that was the little bit make problems. So we have to tune that situation.
got it. There's another question saying, how has the return on investment been with respect to conventional methods of air quality, and then with respect to drone? So I think they want to ask, like, what is the difference in the return on investment?
Uh, Actually, so we have to make the more reference, and then but currently there is when we are using this drone-based real-time air quality monitoring is more usable for the we can measure and then monitoring this every point is the this resident is people is want to check this here and then there something like that, and then we when we install this resident you get, it's a IoT sensors. In that case, we have to install a lot of the sensors deployed. That was the make the cost problems, and then so it's this drone based is a more user very effective solution, I think.
Got it.
Mm.
Any other questions? I would request the audience to put them in the chat or the Q&A section. Um, yeah. Um, I think there's another question. Just give me a second. Yeah, I think. Okay. Which software did you use for air quality monitoring?
Uh, Software is nothing special. Is the monitoring sensor is collecting measure the sensing the air quality, and then the sensor send the measure data through the LTE communication network to the collecting software. There's a collection software is a normal just our customer side already have the those kind of the collecting software is any many kind of the sensors they operate already. So kind of the water quality something like that, and then so to test the system is collect the is air quality sensor information also. Yeah.
Got it. I hope that answers the question. Did you face any regulatory issues during the deployment of this system?
Actually, this in Korea is a regulatory is uh, very similar. Is the PVRS in the case is we have the is a operator is a control of drone control operator have to be reside in in the control center, and then we have to get some approval from the uh, uh, cent, flight approval from the government side. In that case, there's no problem.
All right. I think that is it from the questions. Anything else? I would request the audience to put them in the Q&A section, or yeah, we'll just wait for a minute. So if there are any more questions, um, there's a question uh, for like how many drones are you using to serve this use case? Do you think it would be a scalable solution in the future, since this is a huge issue in third world countries or developed countries?
Mm, yeah, actually, the solution is very scalable. I mentioned is when there is a complaint residence or there is uh, required is measuring point is increased. In that case, we can use this kind of solution. Is we provide a flexible, uh, yeah, flexibly we can get provide the solutions. So the customers is thinking there is expand this kind of the solution to the another area. So we also there's that will be helpful to the is kind of the solve the problems. Actually, there's in Korea is we got many this kind of the dust, the fine dust and the ultra fine dust is came from uh, the factory areas. So uh, there's a lot of the complaint. Yes, it's increased. Yeah.